In the last video, we talked about addition and subtraction of complex numbers, multiplication of complex numbers, and powers of I. We have not yet talked about division of complex numbers. Before we do that, I want to talk about what a conjugate is. A complex conjugate if you have A plus BI, the conjugate is A minus BI. And when we multiply these two things together, nice things happen for us. So if I multiply these, we're going to get A squared minus ABI plus ABI and minus B squared I squared. So notice that these two will add to 0, and this I squared can be replaced with -1. So in the end we get A squared plus B squared, which the interesting thing about this is there's no more i's, no more complex or imaginary units in here. So how do we use that? How do we use this fact? When we want to divide two complex numbers, like 3 plus 5i and 2 minus 3i. First, why would we want to do anything for this? Well, because I is the square root of -1, and we don't like to have square roots in the denominator. We need to rationalize that. We can do that with the i's intact. So we're going to multiply this by the conjugate of the denominator, which is 2 plus 3i and 2 plus 3i, because we know down here that when I multiply those, the i's will go away. So if we multiply out the top, we're going to get 6 plus 9i plus 10i plus 15i squared. And on the bottom, 4 plus 6i minus 6i and minus 9i squared. So if I replace these I squares with -1, in the numerator I get 6 minus 15, which is minus 9, plus 19i, and these two on the bottom will add to 0. We get 4 plus 9, which is 13. So you might write this as minus 9/13 plus 19i over 13. Either of these two expressions are just fine. The last thing we want to talk about is when we have a division and in the denominator we don't have a binomial, we maybe only have a monomial, like 2i. I don't actually need to multiply this by an entire conjugate. I can actually just multiply this by I over I, which is 1, and that's going to give me 3i plus 4i squared and 2i squared. And I think you can see that when I replace these I squares with -1, I get 3i minus 4 over minus 2. And I typically want this piece to be real part and then imaginary part, so we're going to write it as minus 4 plus 3i divided by -2, or 2 minus 3/2 I, dividing each one by the -2. That concludes this video. Thank you.